All right, today we're going to be talking about hyperbolas. This will be the last lesson of the conic sections. Hyperbolas are these black lines that are drawn here. It's kind of like two parts of the curve, I guess, going on here. If you go back to the front page, when we talk about where these conic sections come from, the hyperbolas is when you take a plane and you intersect it with two cones going vertically, and you'll kind of have two parts to these curves. So, if you want the technical definition here of a hyperbola, get back to here eventually. Where's this? There we are. Okay, when you go back here, a hyperbola is going to be the locus of all points, such that the differences of the distances from the two foci is constant. Now, we won't really look at that vocabulary part of it, but technically, and I wouldn't sketch this out here because we're going to erase it in a second, but technically, if you have two foci, like roughly right there and there, if you go and connect that to a point, just a random point on your hyperbola, if you go and find those distances and subtract them, and then you do that for like maybe another point, those distances, when you subtract them, should always be the same distance. And that's the technical definition there of a hyperbola there. So you won't really necessarily need to know that. You're just going to need to know how to graph them. Now, the hyperbola formulas, they'll be very similar to the ellipse formulas right there. If you just notice how there's a minus sign in between, that's the indicator that it'll be hyperbola. As far as extra vocabulary things that you do need to know here, transverse axis and conjugate axis right there. Those are kind of going, they're similar to major and minor axis. The transverse axis will be tied to your A value, and then the conjugate axis will be tied to your B value. So we'll talk about where A and B are in just a second. Also, the relationship between A, B, and C. C helps to get your foci still, but the relationship between A, B, and C is now it's going to be A squared plus B squared equals C squared. So while I'm thinking about it here, let me talk about how you remember what the formula is. Like if you get them kind of mixed up with the ellipse one where it's A squared minus B squared equals C squared. So the way I kind of think of it is, hey, if there's a minus right there, you always go and do the opposite. Here, let's get the writing tool here. The opposite there, sign like that. And if you go back and look at your ellipses, that holds true as well. So let me show real quick here with the ellipses. Yeah, so if you go back and look at the ellipses here, you got plus there, and then opposite sign, you got a minus. So it's A squared minus B squared equals C squared. So that'll be a little bit different there. You're going to have to rewire your brain a little bit there on those. Also, let's go ahead and label on your hyperbola right here some different things here. Now, these dotted lines, these red dotted lines are going to be slanted asymptotes where the hyperbola approaches. To help get the slope of those, we draw that blue little box that's going on. And if you go and label this here, the distance between the center and this vertex right here, that's always going to be your A distance right there. The B distance is going to be this one going up and down. And if you go think about slopes right there, this would be up B and over A. Think of like rise over run. So if you look down below, they'll say that the slope is B over A, one positive and one version that goes negative there. I don't necessarily memorize that, by the way. I just sketch out the A and B values and then just draw the little box there after doing the slopes. The C value is helps you get the foci points right there. The foci points are usually kind of like inside of these little hyperbola curves. So actually C is typically longer than the A value, which will be a little bit different there on that as well. So that's the A, B, and C values on a horizontal hyperbola, and then over here you have a vertical opening hyperbola there. A will still be the distance from the center to the vertex, and then B will be that distance right there, that horizontal one that helps us get the slopes there. By the way, transverse axis is the one connecting the vertices, and then conjugate axis is that one kind of going side to side, the 2B right there. I guess if you want to label one of your foci up there, this would be your C value up there at the top. Okay, so that's the A, B, and C values. Let's now look at the equations, because there's one major difference here with the equations. A squared, go ahead and write this down. A squared is not always the biggest number. And apologize here because I forgot my Apple Pens. My handwriting is going to take a little bit of a hit here, but anyways, A squared is not always the biggest number like the ellipses. Like the ellipses, we figured out whatever the biggest number was. We figured out the location of the biggest number, whether it was under X or Y, and that helped us figure out if it was a horizontal or a vertical ellipse. With hyperbolas, since A squared is not always the biggest, what you're going to be looking for as far as the differences is does it start with X first or does it start with Y first? So if you go like down and look below these different ones here, like you'll have X's and Y's in different spots. Sometimes you'll lead off with the Y's, sometimes you'll lead off with the X's. So that's that. The center will still be H and K. Just remember that X and H always go together and Y and K always go together. So if you have the Y first, you'll have the K piece with it right there. And that's where you got to kind of watch out. A lot of people will accidentally mess up the center on these here. And yeah, I think that's about it there. So I think we're about ready to graph these here. So we're going to start out with this first one here. I'm not a big fan of this first one because they don't actually put like a different, I guess, center point. So for this first one, I want y'all just to get in a habit of maybe putting K somewhere near your Y and H somewhere near your X so we don't accidentally get those backwards. When you write your center point, it's going to always be H comma K, but in our case right here, it's going to be 0 comma 0 right there, just like that. So it was a coincidence that they're 0, 0, but just watch out on the H and K. Be real careful with those. Okay, so your A squared will always be first on these. I don't know if y'all noticed that, but on both equations, A squared is first. So A will be the square root of 9, that will be 3, and then B will be the square root of 25, that will be 5 right there. Here in a moment, we'll go get the C value to do the foci, but the instructions technically don't say to do the foci, so I'm not going to worry about that quite yet. So let's go and start graphing everything. We'll start out here with 0, 0. That's where the center of this is. Since Y came first, I should have hit on this earlier here. Since Y came first, this will be a vertical, opening hyperbola right there. So this will be the second type, the one on the right-hand side. So what that means is your A, which is the distances to the vertices, is going to go up and down right there. Up and down 3. The 5 means you're going to go left and right 5. Let's see if I can count that there right. And then from there, what you're going to do is you're going to make this little box here. I guess like kind of go 3 up and down from the left and right 5 spots right here. And then I want you to make a diagonal line as best you can. You know, feel free to use a straight edge on like a paper test or something like that. And extend those. That is where the hyperbola curves are going to approach. Now remember, it opens up and down, so these are actually going to be the vertices here. You could label them if that helps you remember which ones. And then just kind of get it curving and then approaching the vertical asymptotes. You want to kind of get it real tight there at the edges there. Some people will kind of like curve it like a parabola, but this isn't exactly like a parabola shape. So try to get them approaching as best you can these asymptotes, these slanted asymptotes right there. And then that should be it there. Occasionally they'll ask you for things like vertices, so those are your vertices. We already had those labeled. Sometimes they might ask you for the slopes. I think the homework will do that a few times there. The slopes there, it would be up 3 and over 5, so I would put plus or minus 3 over 5. I wouldn't necessarily remember A over B or B over A, depending on the type. I would just go and count the slopes personally. So, yeah, that's, I think, usually about everything they ask. And then now let's go figure out how to get the foci points. So I'm adding this as like kind of a supplemental thing. So to go find the foci points, you'll take your a squared, b squared, and c squared formula, and then you'll do the opposite sign of this right here. Always the opposite right there, so it'll be a squared plus b squared. So we'll go do 9, I guess, plus 25, and then equals c squared. I guess when you solve for c, you combine that, that's 34, so that'll be root 34 right there. That is approximately 5.8. If you want to sketch it on the graph, you can, but a lot of times we do not graph the foci. But if you want to go up and down, I guess 5 and then a little bit more, that would be where a foci is. And then go down 5 and a little bit more. That'd be where another foci is right there. Okay, but a lot of times we don't require you guys to graph it. However, we'll usually ask you for the foci order pairs. So I'm going to go and list that here. The foci order pairs, it's actually kind of easy. It's just you take your center, 0, 0, and since the foci are going up and down, you're going to add the root 34, add and subtract actually. You're going to add that to the y value since it's going up and down. So it'll be 0, comma, 0 plus or minus root 34. Obviously 0 plus root 34, you could even write it as 0, comma, plus or minus root 34. You can also write them as separate order pairs, or you can be lazy and do the plus or minus part right there. And that's usually all the stuff that we'll ask for on these hyperbolas. So with that being said, let's try out this next one right here. There was a typo here. We keep forgetting to fix this here. So I'm going to change this to y minus 2. It shouldn't really ever be equal. So if you want to make that little change there, let me make sure that matches my notes. Oh, mine's got a plus, but oh well, we'll wing it here. We'll be okay. So once again, we're going to label h and k. Remember, h always goes with x. K always goes with y. So then the center is going to be, and remember, you'll go opposite sides of these, just like the ellipses. It will be -1, comma, I guess negative, or well, here, I guess positive 2. Sorry, I was looking at my notes there. Yeah, so -1, positive 2 based off of what I have here. Remember, a squared is always the first thing, no matter what. So a, therefore, is 3. B squared is 16, so b has to be 4. And we'll go back later and get the c in just a moment. Last thing we need to figure out is which way it opens. If x comes first, it's got to be a horizontal opening one right here. It'll kind of look like this eventually, opening horizontally. So when we do our a value, a is going to go horizontally. We're going to go left and right 3, and those are going to be where the vertices are. So let's go ahead and start it here. So we'll go here and go, what was it, -1, positive 2. Then we're going to go, oh yeah, my notes, and somehow my notes got messed up here, but anyways, we'll go left and right. Since it's opening horizontally, we'll go left and right 3. So 1, 2, 3, we put a point there, that'll be a vertex. And then 1, 2, 3, you can put another point, that'll be another vertex there. Then the B is going up and down, so we'll go up and down 4. I think I counted that right. And then go left and right 3 from those points, just to kind of get this little box for our slopes right there. Okay. Yeah, and then now that we have our vertices labeled, it's kind of very clear that we need to make the graph kind of go in these ways right there. It's real easy to accidentally go too fast and then accidentally draw it going, I guess, up and down there. But it just doesn't look pretty here. I don't really have my Apple Pen, so it's not super precise, but that's essentially what we're going to be looking for when grading on the tests and quizzes. First of all, making sure it's opening the right way, the center is in the right spot, and the vertices and slopes, all match up, I guess. So that'll be that. Let's go back here real quick and get the foci points. You'll do, once again, the formula for it is a squared plus b squared, opposite sign, opposite of that right there, and then equals c squared. And so that'll be 9 plus 16, and then equals c squared. That'll actually be root 25. That'll actually be 5 right there. Came out pretty clean. And you know what? I don't know if we've even seen one yet like this in the notes here. So when you do your foci are going to go left and right, I guess 5 units right there from the center. So you can actually write your foci as ordered pairs. So I don't actually want y'all to write this and leave it like this here, but you'll take your center, -1 and 2, and then you're going left and right. So you need to add and subtract 5 from that point right there. But we can actually add and subtract 5 from the foci. So for the foci in here, don't leave it like this here. Write it as 2 order pairs here. -1 plus 5 would be 4. So you can go 4, 2, and then the other one, -1 minus 5 right there, that would be -6, comma 2. And those would be your 2 foci points right there. So that's kind of a weird one where it doesn't come out as a radical, so you can actually simplify it a little bit better there. So that'll be that. Should be pretty straightforward there on that. So this next one coming up here, I'm going to do something here. I'm actually going to make a change here on the fly. So what I want us to do here, I want us to practice getting this into standard form, but we're going to have to graph it eventually, and I want to do another vertical type here. So I'm going to scratch this out here and modify it just slightly here. So if y'all don't mind doing this here, I'm going to write here. Yeah, let's do this here. Let's go +16. Well, hang on. I better not do this on the fly. You know what? Okay. Let's keep this original here. I got another one here queued up that we'll add into the notes where it'll be another vertical opening one. So we'll do that in a second here. And then I guess we'll talk about the center here. But yeah, never mind. Let's keep this the same here. Sorry, I'm kind of going all over the place here. All right, the steps of getting this into standard form are all the same exact steps that we did with the ellipses. You do want to figure out the one that's going to come first is the positive. So it's positive 25x squared. It's -16y squared. So do not mess around. Do not put the -16y squared first. We'll put it last here. So what I'm going to do is group up here. I'm going to go 25x squared. I'm going to put the plus 100x. We'll factor out in just a second. -16y squared. I guess positive 96y. And then you can go ahead and make sure the constant number is on the other side, which it's already ready to go. Then we're going to factor out, and we're going to actually factor out on both groups here. We'll factor out at 25. That'll be x squared plus, I think that's 4x right there, and then plus blank. On this other group, don't just factor out 16, factor out -16. That's real important right there, because you'll want to factor with the inside stuff left over. You'll want it to be positive y squared on the inside. So be kind of careful there on that. When you divide 96 by -16, you'll actually get -6y, according to my notes. And then parentheses right there. And then we'll bring over the 444, and then we'll add in 2 blanks, kind of making them wide here, because a lot of times you'll have to multiply 2 numbers here when you fill in the blanks. So now we'll do the complete the square process. We've been doing this here for a while. We'll do 4 divided by 2 and then squared. That would be 2 squared, which would be 4. Over on the right-hand side, we're not just adding 4, we're adding technically 25 times 4. You can go ahead and write 100 in right there if you want. Okay, -6y, half of -6 is -3. -3 squared should be 9. And then we'll do -16 times 9. I guess you can use parentheses or a times symbol. Doesn't really matter. Okay. And then we'll start to factor the left-hand side. When we factor the left hand thing right here. This will be x plus 2 squared. The second group will be y minus 3 squared. You'll want to match up the sign with the same sign as the b value. On the right hand side, you're going to have 444 plus 100 and then minus 144. This part will be, if it'll let me write. That is strange. I guess my iPad's glitching out there on the right, but yeah, that'll be negative 144. So when you combine all your like terms, actually, you wind up getting 400 over there on that right hand side. So something that big, you'd probably have a calculator. Okay, then after that, we'll take all of these here, divide by 400. Okay. We want the right hand side to always be 1 right there, and that's why we'll divide by whatever's on the right hand side. You can go ahead and reduce these fractions here. You're going to get x plus 2, and then 25 goes into 416 times. And then 16 goes into 400, actually 25 times. And then this is your equation, and it's ready to graph. So I'll go a little bit quicker here on the graphing just to kind of speed this up here a little bit. The center is going to be the h and k. H always goes with x. K always goes with the y. So the center go opposite sign. This will be negative 2, comma, positive 3. The a is always first, so it's the square root of 16. That'll be 4. And the b will be second, b squared. So the square root of 25 will be 5. Since x is first, this will be another horizontal opening or hyperbola right there. And then we'll go ahead and plot everything here. So we got negative 2, 3. That would be right up there. Let's see, the a was 4, so we'll go left and right 4 for the vertices. 4. And then 1, 2, 3, 4. And then the b value is 5. It'll go up and down 5. This will help us get our slopes. Okay, so there we go. And then now we can go get your slopes. Just kind of, usually I kind of extend them to the edges of the graph. And then just get your, go through your vertices, obviously. Oh, this is it's like the right side of my iPad's kind of being weird. It's not on the right over there. So I have to slide it over there. But yeah, there you go. There's your hyperbola curves right there. So once again, things I'm looking for really just all these points here. Make sure they kind of stand out so I can see them well. And then you should be good. Obviously the center as well. So let's keep that same theme going here. Let's get this one right here in standard form. This is just one I pulled from the book. And just one thing I want to emphasize here is when you have the x squared, the negative x squared plus 3y, you want to move and bring the 3y squared first. You want your positive stuff first. Okay, and then we'll put the negative x squared, and then I guess the negative 4x. And then obviously the 28's already ready to go. The first group you can factor out a 3, you will be left with y squared plus 2y, and then plus, I guess, something here eventually. The second group, even though there's not a GCF number you can pull out, we're going to still pull out a negative 1. And watch out on that. So that'd be x squared plus 4x, and then plus blank left over, then equals 28. Okay. As far as completing the square, I guess I'll write it over here to the side. We'll do half of 2 and then squared. That should be 1. Over here on the right side, if you kind of run out of room like I did, you can just do like 3 plus 3 times 1 like that, if it'll let me write. Half of 4 squared would be 2 squared. 2 squared would be 4. And here's where a lot of people will mess up here. It's negative 1 times 4. So be kind of careful with that there. Okay, let's keep it going here. You factor 3y squared, or well here 3y, and then this will be plus 1, and then squared. The second group you'll have a negative 1, and then I guess this will be x plus 2, and then squared. Right hand side, that's 28 plus 3 right there, I guess 31, and then minus 4, that's going to come out to 27. And then to finish this thing out here, we'll divide everything by 27. It's actually a little bit of an odd number. I don't think y'all would graph something like this here, but when you reduce over here, obviously this will come out pretty good. This will be 9. And then I guess over here, yeah, put the minus in between. I guess this will just stay as 27. So when you square root that for your B value, that's not like really a great B value. A lot of times on tests and quizzes, though, we're going to give you clean A and B values. So this one wouldn't be the greatest to graph. Square root of 27, that's probably 5 point something right there. So one last thing I do want to talk about, we won't graph it here, but the center is where people mess up on these vertical ones. This will be a vertical hyperbola, opening up and down. Remember, the K goes with the Y and the H always goes with the X. So the center is actually -2, -1. So watch out on that there. I have a lot of people mess that up on the vertical types right there. Okay, so that's that right there. Got a few more here. These over here, kind of like the ellipses, sometimes are going to give you some attributes, and then you'll go and figure out the equation for the hyperbola that matches that. Like before, we'll need to do a rough sketch so we can kind of figure out where everything is located. So I'll just kind of do an X and Y axis there, and then we'll plot the vertices, apparently at -3, -6, so like maybe way down there, and then -3 and +2. If those are vertices, that tells you right then and there the vertices are kind of lined up vertically, so this will be a vertical open in hyperbola. Probably should be a little bit wider than that, but that's okay. This is just a sketch here. Like before, to find the center, it's just a midpoint. It's just whatever's halfway in between these two order pairs. There's a lot of ways to do it, but usually I'll just do an average X and average Y. Obviously the vertices here, they both like have the same X value, so the center is going to be -3 comma, and then I guess we'll go through and average the Y's right there. This is -6 plus 2, that would be -4 over 2, that comes out to -2. So that'll be your center, -3, -2. Also, with your vertices are always going to be tied into the A value, should help you find A. So if you take the distance from -3, -2 to like maybe that point right there, it doesn't matter which one you choose, but if you go and take the +2 and then subtract -2 right there, this will get you your A value, which is 4 units away. Okay. Now, the C value is always tied into the foci. That's not going to help us right away with the equation, but we can use the -3, -2, and then this value right here that to help us find the C value. So C, you just take the 3, and then you would subtract off the -2, so minus -2 like that, and then I guess C will come out to 5. Okay. And then from there, you can actually use your formula to go and find the B value. Remember, with hyperbolas, it's a squared plus b squared equals c squared. And then plug in what you have here. You have 4 squared, which you can go ahead and write 16 right away if you want. C squared is 5 squared, so that'll be 25 minus 16 right there. That'll be 9, I believe, and then yeah, 9, and then that should come out as a B value of 3. But you have to find C first before that. And then now that we have the fact that it's a vertical opening one, we have the center, and we have the A and B, we can go ahead and start putting all this together into an equation. So let's see here. I guess I'll squeeze it in over here. Here, I'll write it down below. I'll just write small here. So if it's a vertical opening one, we need to start out with y. It's always going to be y minus k and then x minus h. So this will be actually y plus 2 squared. So be really careful there on that. Minus sign in between. X minus negative 3, that'll be x plus 3. And then square, don't forget your squares. Equals 1. I accidentally covered up my minus, so I'll just put that right there. And then the a squared will always come first. A squared will be 16. B squared will be 9. And yeah, once again, make sure minus is in between them, and then that should be your equation right there. All right, let's do the one here. Sometimes they'll give you the length of the conjugate axis or transverse axis. So yeah, let's run through this one here. Vertices at 3, 2, and 3, 6. So let's plot those there real quick. 3, 2 roughly there, and then 3, 6 is actually up there. So actually, I guess it's another vertical one. So that means y will start first again. Maybe we should have made it to where it's an x equals, but that's okay. The center, start putting that together. Obviously the x should be 3, something. This thing will write, okay. And then the average y values, you could probably do it in your head. It's just 6 plus 2 divided by 2. That's 8 divided by 2, and that should come out to 4. The distance from the center to one of the two vertices should be the same, whichever one you choose. When you subtract those, it does look like that comes out to an a value of 2. And then the length of the conjugate axis, this will actually help you find b. This is 2 times b, which has to be 10, which means b is 5 when you divide right there. What's nice about this one, we don't have to mess around with the c or the foci. We can go ahead and start putting this together. Remember, if it is a vertical one, it'll start with a y. It'll be y squared, it'll be a minus, that'll be an x minus something squared equals 1. A squared will always be first, so it'll be 4 there right away. B squared will be second, 25. And then remember h and k. K goes with y, so it's minus 4 and then minus 3 there with the x. So be careful, real easy to mess that up there. All right, 2 more concepts here. Thank you guys for your attention here. 2 more concepts. Eccentricity again, or eccentricity, I don't know how to say it, but we'll go with eccentricity. But it is the same exact formula. It is still going to be c over a, just like with the ellipses. Okay, and the big thing, I guess, with eccentricity is with the hyperbolas, it is actually going to be greater than 1. Feel free if you just want to do the greater than symbol right there. So you have the circles, the eccentricity is exactly 0. The ellipses, it's a little bit between 0 and 1. And then hyperbolas, it'll be greater than 1. So now we're going to go and figure these out here. So if I remember, I think it's the bigger the eccentricity is. I can't remember if it's like I think the slopes are steeper, if I remember correctly. It'll be like a tighter hyperbola, I guess. So anyways, let's go and find it here. Usually for eccentricity, you're going to have to go find your c value. So let me do that here real quick. Remember, a squared is always first, b squared is always second. When you do your formula, it will be the opposite of this. So a squared plus b squared equals c squared. So 48 plus 36. And then equals c squared. That will be root 84. Don't worry about simplifying these because a lot of times these are going to come out to decimals anyways. So don't spend your time simplifying the radical when we're just going to type it in our calculator for a decimal anyways. So that is your C. Be careful, the A is not 48. The A is root 48. And once again, don't spend time simplifying that. Just now go take those right here and then do your eccentricity formula. It'll be root 84, the C, and then over root 48. Okay, and I do not have that written down. Let me see if I can grab my phone here and type that into my calculator, so bear with me. Sorry for my lack of preparation here. So I'm just typing in the calculator off screen here, root 84, and then divided by root 48. And if I can type it correctly, yep, there we go. I got written down 1.322. Not sure if they said to round. They didn't say to round, so that would be good enough. And obviously, if you look at that, that's bigger than 1 right there. So that's eccentricity. Fairly simple, not too much going on. All right, the last category of questions here is going to be these here. The big thing with these here is we want y'all to, without going and completing the square, we want y'all to be able to identify if these are ellipses, circles, or parabolas. So we're going to make a little chart of things to look out for. A lot of times we won't really see the line, but a lot of times the line will have no x squared or y squared terms, I guess. So like something that's linear usually won't have x squared or y squared. A lot of times we won't throw those at you. These are kind of the conics we're focusing in on in this unit here. A parabola, you will have just x squared or y squared, but not both. Okay, so down below we'll be able to kind of look at them and then determine based off of that. Okay, for a circle, you're going to have x squared and y squared. Really, actually, for all of these down here below, they're going to all have x squared and y squared. Big thing that you need with the circle is you also need the same coefficient out in front of x squared and y squared. I'll point out here in just a second on the examples below. An ellipse, you're going to have x squared and y squared, and you want the same sign but different coefficients out in front. If they have the same sign and same coefficient, it winds up being a circle. And actually, you know what? Go ahead and add that into the circle here. It's kind of implied if they're the same coefficient. If they're both like 3 and 3, then that would be a circle. If it was like 3 and -3, technically not. But yeah, they would need the same sign, I guess. I think that's kind of implied there, but you can add it in if you want. Hyperbolas, which we looked at today, you need x squared and y squared, and usually they have a minus in between the equations, so a lot of times you just need x squared and y squared, and then you just need different signs out in front of those. Okay, they could actually be like a coefficient of 3 and a coefficient of -3, and since they have different signs, it'll still be a hyperbola. So it doesn't matter if they're the same number. So now looking down below, first of all, make sure these are set equal to 0, because I think like on some of the warm-up questions, maybe even test questions, sometimes they'll have things on different sides, so make sure they're equal to 0. All of these are already equal to 0, so we're ready to go. But sometimes they'll kind of throw some curveballs at you there. So like looking at this first one here, I notice we have both x squared and y squared. It definitely cannot be a parabola. They're both positive, so it can't be a hyperbola either. So it's either going to be a circle or an ellipse. Since they have different coefficients, that means this has to be an ellipse. Okay, don't be the person that tries and solves and completes a square on every one of these, because you will run out of time there. You're supposed to look at these and just, if you know your rules here, it speeds it up. Notice here on the next one here, you have both x squared and y squared. Once again, it cannot be a parabola. You have the same sign between them, so it's either a circle or an ellipse, and since they both have a 4 out in front, this will wind up being a circle. And that's because I guess they have the same coefficient. Okay, next one here. I only have a y squared. When you only have y squared or x squared, but not both, that'll be a parabola every time. That should be the easiest one to get right there. Hopefully, when you just see the one square thing, you think parabola. And then you could probably guess this one's going to be a hyperbola here, because that's the only one we haven't done. The reason it is a hyperbola is you have both x squared and y squareds, but different signs. So obviously it's going to be a hyperbola. Like I said, just be kind of careful. If they give you one like, I don't know, like 3x squared plus blah blah blah, blah and then equals 3y squared on the other side, when you subtract it over, it will be negative, and then therefore it should be, hyperbola again there. So just make sure it's always set equal to 0. Otherwise, you might get some errors there. So, all right, anyways, that is all for today, I believe. Yep, that is it there. So thank you guys for watching.